once again, we're faced with a situation where we're given K and an equilibrium statement, and we're asked to find out what the concentrations are when the system reattains equilibrium. So, set up our ice table like normal. And here we have our changes, minus x, here it's plus 2x, and so at equilibrium this is 1.55 times 10 to the minus third minus x, and this will be 2x. And we can plug it into our equilibrium expression. K is equal to I2 2x squared divided by our starting material and then once again we can rearrange and solve for our equilibrium expression. Now, we could do a quadratic. There are no simplifications that we can do related to the math, and so we could solve this with a quadratic. Multiply it out and get it into the form of the quadratic. So we could bring this over, multiply it out, rearrange, solve for x, put it in the form ax plus b, ax squared plus b is equal to c, plus c is equal to 0, and we're done. Ish. All right. So, but again, our goal in many of these cases is to try to find ways around that. And for this one, there's actually a simplification we can do that is not to do with the math, but it has to do with K. As K is so small, the reaction is dominated by the starting materials. X is going to be minimal. And so we can use the assumption that 1.55 times 10 to the minus third minus x will be approximately equal to just 1.55 times 10 to the minus third. If this number is vanishingly small, we just can ignore it. That this number will be non-affected by this small x. So if we do that, then let's make this assumption. So we're going to assume that this will be approximately equal to 1.55 times 10 to the minus third. It's important that we hold on to that. If we make that assumption, then this here simplifies to 2x squared divided by 1.55 times 10 to the minus third equals 3.39 times 10 to the minus 11. Well, that's a number, that's one constant. So we can multiply these values out appropriately. So this becomes 4x squared is equal to 5.25 times 10 to the minus 14th. And we can divide by 4. This becomes x squared is equal to 1.31 times 10 to the minus 14th. And then x is equal to, take the square root of both sides, 1.14 times 10 to the minus 7th. And now we can plug it back in, and we can check during this time. 2x is going to be equal to 2.29 times 10 to the minus 7th, and 1.55 times 10 to the minus third minus x is going to be equal to 1.55 times 10 to the minus third, well within our assumption. And then our check, k will equal 2.29 times 10 to the minus 7th squared divided by 1.55 times 10 to the minus third will equal 3.39 times 10 to the negative 11. Well, pretty much exactly what we expected. So the concentration we care about for the iodine is this. The concentration of our I2 is given, and so we are all set in this case. Check the assumption. As long as this is valid. Usually our rule of thumb is within about 5% of the value. This is 3 orders of magnitude. This is $1 out of $1,000.